Good evening once again. Let me share my screen. Okay, so I hope screen is visible. Yeah, fine. So we were doing numericals on center of mass, and this entire series is devoted to center of mass and its applications related to center of mass. Okay, so now let us start with the problem here. So consider a gravity-free hall in which a tray of mass m. Okay, I have a big tray. I have a big tray. I have a big tray carrying a cubical block of ice, small massium. I have a small massium here, small massium, and edge L at rest in the middle. See, it's very clearly specified at rest in the middle. I have kept it at the rest in the middle. My way of writing cube is like this. Okay, fine. Anyway, okay, so that's on the middle. So what is it? At edge L of mass M and edge L. Okay, this is the edge L, the length of the cube. Okay, this is the length, this is the height, this is the breadth. It's given to you. Okay. If the ice melts, by what distance is the center of mass of the tray plus the ice crystal deemed? Which means what? When the ice melts, water, it becomes water, and as a result of it, water will start flowing like this, right? It will start flowing like this. And after some time, you observe that if this is a tray, the water will be completely on the surface like this. Will be on the surface like this. Agreed? Okay. So therefore, now initially the center of mass of the tray would be at this point, and the center of mass of the ice would be at this point. And finally, what happens is, okay, so these two are almost on the surface. So center of mass would be at this point, right? So this is what, as ice melts into water, the center of mass will also shift towards the tree. It's not towards the tree, towards the tree. Okay. So this is one of the student response that I got. Now, this is a misconception. Why misconception? Yeah, this is very similar to what you have learned, right? Okay, ice melts, so becomes water. Water cannot stay here. Or towards it in such problems, what you need to know is you need to know what is given here. Gravity free hull. When ice melts, what will happen to the ice? Ice will flow down. Why should the water molecules flow downwards? Why can't it stand there itself? The very reason is because gravity is pulling it, right? So molecules are now stacked like this, one above the other like this. It's been stacked like this. It's been stacked like this in a cube, water molecules cube. Okay. So now when gravity is present, then automatically the topmost molecule or the bottommost molecules, they will lose an imbalance, and as a result of it, the molecules will flow down. When there is no gravity, none of them are being pulled downwards, right? So as a result of it, they will just stand there itself, which means nothing will happen to the center of gravity, right? So if ice melts, by what distance the center of mass of the tray plus the ice system deemed? Okay, so nothing will happen. The center of mass of this would be at a distance of L by 2 for the ice and as well as for the tray. And for the tray, for water molecules and for the tray, it will be at this point, at the base. So as a result of it, nothing will happen to it. Okay, so therefore, the center of mass will remain at the same position. We still want to have a math behind it. What is the value of the center of mass? Then what you need to do? This mass is at this point. Okay, this capital M is at this point. Then the distance between these two. What's the distance between these two? This is L by 2. Because you see, the whole thing is L here, right? So therefore, this should be L by 2 at the middle point over here. L by 2 over here. So this is the tray. This is the center of mass. The center of mass of the tray. The center of mass of the ice. Let me write down center of mass of the ice and center of mass of the tray. This is what we have. Now, what is he asking? What is the center of mass of the tray plus the ice? Okay, where is it located? Because he has also given you some values, right? So you need to find out that value. So what we will do, let us first put a coordinate axis. Where is the coordinate axis? Consider this y-axis here. This is a y-axis and this is my x-axis. X-axis. So towards it. Now what will happen here? Now you see the entire mass is focused at this point. Let me call this mass as M, this mass as capital M. That's what is given to you. Now we need to find out our center of mass. So do we have XEM? See, let us try XEM also. What is wrong? XEM is equal to M1 x1 plus M2 x2 divided by M1 plus M2. Now, what are the coordinates of this capital M? 0, 0, because of the origin. What are the coordinates of this one here? X coordinate is 0, y coordinate is L by 2. So, as a result of this, x1 and x2. So, this is x1, this is x2. x2 both are 0. So, XEM is equal to 0, right? Now, let us look at YCM. YCM should now be equal to M1 Y1 plus m2 y2 divided by m1 plus m2, which should now be equal to, what is m1? M1 is the mass of the tray. So there should be m into 0 plus m2. What is m2? M2 is nothing but L by, m itself. M into y2, it's nothing but L by 2 divided by m plus m plus m, which should now be equal to m into L divided by 2 into m plus m, right? So thus, you see, we have got an answer for the center of mass of the whole system. Did you understand what we are doing? See, we took one system here, we took another system over here, and as a result of it, we found out. See, this is applicable only in case of gravity-free Hall. Okay, if you ask me what will happen in case of Earth, you bring the same cube, put it on Earth, the same experiment, if you do it, then definitely water will now start floating like this. You need to find out what is the thickness of this layer. If I need to find out what is the thickness of the layer, which will not be equal to L, okay, which will be very, very small. Could be around T or D or whatever it is, and later on you need to find it out. Okay, which is really difficult. Not difficult, okay. So that's the way how you need to do it. Anyway, so this is the answer for this particular problem. Thank you, friends, for watching. And if you like this video, do share and subscribe to my channel for further updates. Every day at 7 p.m. you do get one video which is on some concepts in physics. It could be misconception, not even concepts. It should be in misconception physics. Thank you. If you want to see my old videos, you can visit to my website ratankar.com, and I have put across all the videos there. You can log into it and you can go through it also. Thank you.